Okay, guys, today you should have page 12. So we finished page 11 and reviewed that a fraction is really just a division problem. That's really kind of the main point of all that. A fraction is just a division problem. So we're going to do a few more examples on page 12, and then we're also going to remind ourselves of another way, besides fractions and decimals, another way that we can write some rational numbers. So here we go, page 12. All right, on your practice last night, you, in Canvas, it said big in the instructions, go ahead and use a calculator. Let's do 3 more examples here without a calculator to make sure our brain is still processing what is your calculator doing for you when you use your calculator. First of all, right here for this, you have a couple of options when doing this calculation, and I'm going to share them both with you. Let's review right now this idea of changing this to improper. You did it on an assignment last week, but remember, you multiply the whole part by the denominator and then you add it to the numerator. So 4 times 10 is 40 plus 3. This is really 43 over 10. And a lot of times you guys do a little better if you change that first, because then you don't forget to put the whole number back on it. So now you know that this is really 43 divided by 10. So that's really the calculation that you're doing. It is always the numerator divided by the denominator, always the top divided by the bottom, because that's what this bar means, and mathematically you have to follow that in order. Numerator divided by the denominator. So this means 43 divided by 10, this means 43 divided by 10, and this means 43 divided by 10, okay? I added my decimal with a couple zeros, and now I'm going to go right into this. 10 goes into 43. It does go into 43 because it's improper. Guess what? It goes into it 4 times. Doesn't that make a lot of sense that we should actually have a 4 in the ones place? This is supposed to be equivalent. We had a 4 in the ones place right here. So we are definitely still going to have a 4 in the ones place in decimal form. Okay, so 4 times 10 is 40. Subtract, bring down. 10 goes into 33 times. 3 times 10 is 30. Subtract that remainder of 0. Remember, that automatically means, I can jump to this right now, this automatically means that I'm dealing with a terminating decimal. Now let's go back up and tell ourselves, here was my original fraction, written as a mixed number. 4 3/10 is equivalent to 4.3. Oh, well, of course it is. How do you read this? 4 3/10. How do you read this? 4 3/10. Just a different way to write the exact same thing, okay? Here we go, let's do this one. 9 over 11, that really means 9 divided by 11. So again, this fraction right here means 9 divided by 11. This pink statement right here means 9 divided by 11. And here we are in green, 9 divided by 11. I'm going to copy my decimal up. 11 goes into 9 0 times, so let's keep moving on. 11 into 90 is 8 times, because 8 times 11 is 88. That's the closest we get without going over, like Price is Right. Subtract and you get 2, bring down a 0. 11 into 20. 11 into 20. Well, 2 would be 22. Oh, that's too big, so I can only go once, right? 1 times 11 is 11. Subtract and get 9. I'm not getting a remainder of 0, so I got to keep going a little bit. Bring down another 0. Oh, here I am, 11 into 90 again. We already did that. That's 8. 8 times 11, 88. Are you guys seeing what's going to happen here? If I keep going one more time, look at this. This is repeating. It just happens to repeat with 2 values, but both of them consistently repeat. If I kept going with this long division, it would keep doing that. So this is repeating. I'm not getting a remainder of 0. I'm just getting 20, 90, 20, 90, 20, 90, which means I'm getting 8, 1, 8, 1, 8, 1. So 9/11 is equivalent to 0.81 repeating. So I put the bar over the 8 and the 1. If you were typing that into Canvas, remember you'd put the brackets around both the 8 and the 1. Okay, one more long division. This one is already written as an improper. So this means 15 divided by 4. This means 15 divided by 4. And this means 15 divided by 4. Here we go one more time. Make sure you're still writing everything down with me. 4 goes into 15 3 times. 3 times 4 is 12. Subtract, bring down. Sure you got all that? 4 goes into 30 7 times because 7 times 4 is 28. Subtract, bring down. Not done yet. Don't see a pattern. Haven't gotten a remainder of 0. 4 goes into 25 times. 5 times 4 is 20. I just got my remainder of 0, which of course means that this is a terminating decimal, and 15/4 is equivalent to 3.75. Now, I just want to make a note off to the side here to make sure. I know you practiced it last night. You're going to practice it some more tonight on your math practice or right after you're done with these notes. Let's give ourselves a reminder that when you type it in the calculator, it's a squishy little word right there. You can use the calculator, absolutely. And just remember, the calculator is just doing this long division for you. But if you see any of these fractions and you're typing them in, always remember to do numerator. Let's use the fancy words first. Numerator divided by denominator. Denominator. And this, sometimes we say it this way, top divided by bottom. The number one mistakes I see students make when they're using their calculator on this is that they do it the wrong way. They just always want to type in the bigger one first, and that is simply not how it works. It does not matter which one's bigger or smaller. It matters what's the numerator and what's the denominator. So with this calculator review, I'm also going to show you one more way you could do this instead of changing it to improper. You could just do the fraction part. Look, numerator divided by denominator gives me 0.3. And then you just have to remember to put that 4 in the ones place. So if you want to be able to skip changing it to improper, you can. You just have to make sure you do the top divided by the bottom, and then you have to remember to put it back as in the ones place. If there was a 4 as a whole, there will still be a 4 as a whole. If you're worried you're going to forget that, change it to improper, and then look, I can still type this pink part in. 43 divided by 10. Numerator divided by denominator, 4.3. Let's double check these ones. We did the long division. Let's let the calculator do the long division for us and make sure we got it right. Numerator divided by denominator. I see 0.81818181, and then it stops at 8 because my calculator runs out of room, but I know the next number is going to be a 1. Okay, let's check the last one here. 15/4, 15 divided by 4, 3.75. Now, I am perfectly okay with, at this point, if you're like, okay, I get what we're doing here with the long division. I'm happy to let my calculator do the long division for me. I'm happy for you to let the calculator do the long division for you as well, as long as you keep in your brain the right order to do it in. Because as soon as you start mixing up the order, it tells me you're not quite processing why you're doing what you're doing, and I always need you to process why. Okay? Now, one more form we need to remember and be good at. If we move to this next section, it says, go back to the last 9 problems. 9? We only did 3. Oh, they mean the ones we did yesterday as well. Okay, so we're going to go back to all the last 9 problems, and we're going to rewrite them all as percents. You know what I'm going to do first to make sure I have it is I'm going to write down what they all are as decimals first. Okay, so I'm going to go back through. I got the decimals. I wrote them down in blue, so I'll write them in blue again. I'm going to go back through, and let's remember, so let's flip back. Okay, so I'm writing down these. So number 1 was 0.875, so I'm coming back here, and I'm going 0.875. And first, I'm just writing them all as decimals. I got them as decimals. Let's come back and write them. Number 2 was 0.45. These are the problems we already did. Number 2 was 0.45. Number 3 was 0.5 repeating. Okay. Number 4, we got 0.64, 1.416 repeating, and 0.8. Okay, I'm going to write those down here. You guys still with me? All I'm doing is writing the decimals we already had. 0.64. Is that right? 0.64. I don't know why that one seems weird to me now. You guys have found I make some mistakes in these videos. 17 divided by 25. Yeah, see, look at that. 0.64. That should be 0.68. And you know what I see right here? Funny if you didn't catch that yesterday, we caught it now. This right here, why did I subtract that and get 1? That's silly. Okay, that's 200, which is why this is 8, because 8 times 25 is 200. Honestly, Miss McGowan. I always have to make mistakes just to make sure you guys aren't getting, too bored in the videos. You guys have fun telling me that I'm wrong, so I got to give you that opportunity. Okay, some of you probably caught that yesterday and told me. I just don't know yet because I'm making the video right now. So that one is 0.68. That didn't feel quite right. So 0.68 and then 1.416 repeating. And then number 6 was 0.8. Number 7, we just did that. That's right here. We got 7, 8, 9 right here. 4.3, 0.81 repeating, and 3.75. Okay, so how do I take these values and turn them into percents? Well, let's give ourselves a little bit of review information over here, as we like to do. Percent, the word percent, and we're going to work a lot more with percents later in the school year. This is just a quick review to make sure you remember they're a part of the rational number group. It's a different way we can write things. Percent literally means, we're going to write the word percent over here. Percent literally means, you ready? Per means out of, and cent means 100. Okay? Percent literally means out of 100. So when I have a percent, so like if I started you with, okay, 82, let's say I said 82%. 82% would literally mean 82 out of 100. So actually a percent, what a percent is doing is dividing by 100, because we know that's what a fraction is, right? Per means out of, so if I put it out of 100, I'm really doing 82 divided by 100. And of course, if I type that in my calculator like we've been practicing, if I change this fraction into a decimal, 82 divided by 100, oh, I can also put that as a decimal, 0.82. So to get from the percent to the decimal, really what happened here is divide by 100. That's really what happened, because percent means out of 100, which makes it a fraction, which makes it a division problem. Well, notice all of these are going the other direction. What I want to do right now is I want to turn a decimal into a percent. So if I was going back the other way, if I had, say, 0.73, and I wanted to turn it back into a percent, guess what I would do? Instead of dividing by 100, I'm going to times by 100. And I can type that in if I need to, or do it in my brain if that works for me. But if I times by 100, oh, that just takes me to 73%. So you can work back and forth. You're either dividing by 100 or you're timesing by 100. So in all of these problems here, if I have a decimal and I want to make it a percent, all I have to do is times them all by 100. Now, I want all of you right now to take a minute. Okay, keep writing this with me. Here we go. You still writing them? Write it on every single one so your brain processes what you're doing. You write that on every single one? That's what we're doing on every single one. You are now going to pause the video for a moment, and actually type that in your calculator. The reason I want you to type it in your calculator is because we tend to make mistakes on some of these that go farther than the hundredths place or that go less than the hundredths place. We tend to make a few mistakes. Like you guys want to tell me that 0.8 is 8%? It absolutely is not. Type that in your calculator and see. So pause the video for a moment, type them in your calculator, and see what you actually get. Ta-da! Look really, really closely at these. Pause the video here if you need to, and look at how I formatted all of these, okay? Yes, if you have more than one whole in a decimal, you have more than 100%. Yes, if you have a repeating part in the decimal, you can still have a repeating part in the percent, okay? And 0.8 is not 8%, it is 80%. And we'll practice percents a lot more as we move forward, but to summarize, again, pause right here if you need to, if you haven't had time to write those all down. So I'm going to move away from it. What is a rational number? Well, truly a rational number is any number that can be written, you ready for this? As A over B. That's the true official definition. We're going to give ourselves a couple notes right now about what that really means to us. So any number that can be written as A over B, well, that's of course fractions. But we now definitely know that if it can be written as a fraction, it could also be written as a terminating or repeating decimal. One of those two, and it depends on if the long division ends with a zero remainder, terminating, or if it keeps doing a pattern like 20, 90, 20, 90, 20, 90, that's when you get repeating. So a fraction or a terminating or repeating decimals, terminating or repeating decimals, and percents. Those are all different forms to write the same kind of number. And which one do you use when? Well, it really depends on the context. Sometimes fractions are the most useful, sometimes a decimal is the most useful, and sometimes a percent is the most useful. All right, so these are all equivalent forms, different types of rational numbers. You are going to practice some more conversions on your practice here, and we're getting close already to being ready for an assessment on this conversion stuff. So let me know if you have any questions. Good luck.